Hi, good morning, everyone. I hope you have a good day. Now I'm talking the final project presentation for the multivariate statistics methods. I'm using the canonical correlation analysis for the project, which I have done in the summer paper. The data for this project analysis is the survey data, which I collected in August 2022 this year. The data is drawn from the 105 firms. These firms, the manager of these firms give the data on their sales turnovers, total assets, the account of employees, and also their perceived cooperative transaction specificities as provided by the firm's managers. All these firms are in one industrial cluster located in Jiangxi Province, China. There are total 276 firms in cluster, and all these firms have very high homogeneity, and they are competing on the same industrial sector, which is optical glass code processing and also the assembly of optical components. In the summer paper project, I have done the multiple linear regression and also the logit regression to analyze the two hypotheses, which are the association between the size of firm and also the firm's propensity to negotiate competition, and also the probability of actual occurrence of competition in the same cluster. Competition is a managerial term combining the cooperation between the firms and also the competition between the firms. Is a very interesting topic on the interfirm relation research. The purpose of this multivariate analysis project is to try the exploration between two data sets. One is the firm size, the other one is the cooperative asset specificity. The first data set of the firm size includes three variables. They are the sales turnover and the total assets, and also the total employees account of the firm. The second data set is the perceived assessment of the firm's managers on their assessment on the specificity of transaction asset. Even though we know the transaction cost economics theory has the indication that the small size firm normally has the larger or higher average cost in their market transactions. So therefore, the relations between the firm size and their cooperative asset specificity would be explored, would be latent. However, we need to explore this association rather than confirmed this association. Therefore, I like to use the canonical correlation analysis. I think it's adequate to use this analysis method to find out, to try to identify any correlations between the two data sets, which is firm size and specificity ratings. As long as I can do the canonical correlation analysis, I have checked out what assumptions should be available. For this correlation analysis, we don't need the assumption on the normal distribution of data. However, if the data set has outliers, or the various variables have strong multicollinearity, we can infer that canonical correlation analysis would be biased. And we know that canonical correlation analysis is mathematically beautiful, but it's very difficult to interpret the outcomes because we have the correlation between the data sets, but we do not have any prior theoretical interpretation or argument on these methodologies. But however, I think it's still useful to adopt this method and to identify any correlation between different groups of data. And these findings may give us any help or any inspirations to explore under-discussed relations between the data. Therefore, I have run the SAS program to analyze the firm-side data and the ratings of specificity. I select some tables of SAS outputs to display the results of correlation analysis. This table is showed up the correlation analysis, and it displays the three canonical variates with their eigenvalue and their cumulative explanation on the data variability. So from these three variates, we can find there's only one. The first one is statistic significant, and its eigenvalue is as low as the 0.2668. However, the estimation of these estimation models are significant. For example, the Wilks lambda is significant. From this table, we can see the standardized canonical coefficients of two groups variates. The one group is a specificity V. They have different coefficients with the original 5 ratings of set specificity. The table below is the second variate regarding in terms of firm size, and we can see the size U1 has rather stable coefficient with the 3 firm size variables. This table gives us the ideas on the correlations between specificity variate with their own group of data set, and also the firm size variate, size U1, size U2, and size U3 in relation to their own 3 variables in the same group of set. However, the two tables on the bottom also give us the correlations between the size variate with the other group of data set. Also, the specific variate with the other the opponent group of data sets. So basically, we can see we can find out from the loading matrix that the size U1 has strong correlation with all 3 variables in the firm size, but the size U2 and the size U3 do not have the strong correlation. Regarding the specificity variate, the specificity variate 1 has obvious loadings, and the loadings are greater than 0.3 in relation with the firm size variables. So from this outcome, we may suppose there's one dimension of specificity which can be explained by the variables of firm size. This can give us a kind of implication that these two groups of data sets may have one kind of correlation, and we may use this correlation, this implication to explore any further theoretical argument, and we can use other methods to test the hypothesis if we have. This is the last slide. We have the conclusion from the canonical analysis. There's only one canonical variate with significance, and it can account the major data variability between the correlations of two groups of variables. And none of the size variate has sufficient correlation with other data sets. So therefore, these correlations are not strong to discern and explain anything. But however, we still have one specificity variate with more than 3.0 correlation coefficient with the firm size. So this could be one useful implication to explore any hypothesis between the variables on firm size and on the set specificity. That's all I can share with you. Thank you very much.